Hello everyone. In this video, I'll be telling you about the basic abstract knowledge about FindBugs software that a novice should know in order to use the tool to its full capacity in future. This video is the first of its kind and will also serve as the base of our coming videos in which we will guide you how to use FindBugs from scratch. This is the general information about the team responsible for the whole project. The purpose of making video tutorials about testing tools firstly is to make it easier for aspiring coders and testers to use different tools. It also aims to encourage testing along with coding. Testing and coding goes hand in hand, and as we all know, and a developer should always look for most suitable and appropriate tool to test his code. These videos will give him a general description about the tool and help him make a better choice. Now, about FindBugs. FindBugs use static analysis of the code and look for over 200 bug patterns. It inspects the Java bytecode saved in form of compiled class files to find potential bugs. Now we'll talk about the type of analysis this tool does a little later. FindBugs improves the efficiency of the runtime by highlighting the bugs in the bytecode itself. One of the most helpful features of FindBugs is that it classifies the bugs into categories. We'll look into these categories in detail shortly. Now, what is static analysis that we've been talking about? Broadly, there are two types of analysis, static and dynamic. Static, as the name suggests, is this analysis done on the code before it is executed. And dynamic analysis is done when you execute the code. After executing, the dynamic analysis is done, and if everything is in order, you get your expected output. In most cases, the static analysis is performed on some version of the source code, and in other cases, some form of the object code. FindBugs particularly analyze the Java bytecode, which is saved in the form of compiled class files to detect occurrences of bug patterns. Now about the working. FindBug classifies bugs into categories based on the possible severity and impact they have on the whole code. These classes are namely scariest, scary, troubling, and of concern. Now the order is pretty much given in the name. This classification makes this tool stand out with respect to others, as this helps in prioritizing debugging and even to judge a code. And remember, FindBug analyzes the bytecode, not the source code. This tool doesn't concern itself with the warning errors as of the naming nomenclatures and indentations. Naming nomenclatures, as in many tools show a warning if a variable is initialized as a, as that is not a good coding practice, but as long as it works fine, FindBugs don't raise a issue. Now, what is the advantage of static analysis? Firstly, it does not require the code to execute. It analyzes the bytecode and finds potential bugs. This saves time and is more convenient. Then, analyzing bytecode covers every corner of the code and finds maximum potential bugs. Moreover, if you are in a development cycle, static analysis detects potential bugs early, and hence the probability and possibility of you going back is less, which is more cost effective. Our views about the tool. Personally, this tool is optimal to use while in a coding competition, as anybody will opt for a static analysis, and the depth of the search, the field of bugs, and then the classification is optimal for those situations. Like cases of segment tree and date formats are some situational examples which FindBugs helps us to solve. Moreover, like any other tool like PMD, it does not show false positive errors like about the length of the variable name and suggestions of the brackets and loops. These errors are important sometimes, but sometimes ignorable too. But FindBug just points the bugs which really matters. And the best part, firstly, FindBugs gives a detailed description if you want to, as of why a particular bug is harmful. Common but fatal errors of error out of bounds and mistakes in the hash set pair are easily detected. And as we have talked earlier, the classification of bugs is the USP of this tool, and no one can imagine its usefulness. Moreover, the efficiency of the tool is good, the rate of false reportings is found less, and it helps in recognizing bad pieces of code and help to avoid them in the future. The worst part of the tool. It requires a lot of memory and relatively fast CPU. It does not detect dead variables and dead functions. It detects only some types of infinite loops too. These all things will be made you clear, and it will be demonstrated to you in coming videos. In possible improvements, we would say that if FindBugs can come up with a quick fix feature, then that would be very helpful. Moreover, it should be able to find dead variables and dead functions, although it finds some dead codes. We will cover all this in the demonstration video. So this was the basic of FindBugs and our views on it. In coming videos, we'll demonstrate you the installation processes. Then we'll check the limits of the FindBugs by demo code, and at the end we will use FindBugs on a big project and see how much it enables us to debug it. For any queries, you can contact at this number and drop an email at this. Moreover, you can use the link for the reference materials of the course. So see you in next video.